turn each of those parentheses into 0? Let's start out with just right here. What would turn this into 0? We will do that eventually, but right now if we're just trying to get the x-intercepts, we're just saying what makes it be 0. So what would turn that to 0? What about this one? So if it's actually, they're both negatives, that means we have 3 twice. Yeah, so we have 3, and if we have it twice, we're going to write it like this. 3 with a multiplicity of 2. And then just opening that up to everyone, what happens if it has a multiplicity of 2 with 3? It's going to bounce. Okay, great. What about right here? What would turn this to 0? So that would be a positive I, and this one would be a negative I. So I'm going to do plus or minus I. So we have 4 roots. We have 3, which is used twice, and we have a plus or minus I. Now coming over to the x-intercepts, which of these will be x-intercepts? The 3 used twice, right? Because only real roots turn into x-intercepts when we graph it. Okay, now I wanted you guys to practice multiplying out these. Were you able to get rid of the ugly? Let's check it out. So now we're going to do the lobster claw, or you can also think of it like this. It's a tidal wave. You see it there? Okay. So we've got x squared plus ix minus ix minus I squared. Middle terms cancel out. And then what does I squared turn into? So it's minus a negative 1, so this is x squared plus 1. And then technically from there you'd still need to multiply this out. This turns into x squared minus 6x plus 9. And then you could go and multiply it out. I feel confident you guys can do that on your own, though, okay? You guys get the idea, though, how to do this, right? Okay, we're going to jump to some other examples. Before I do you have any questions on that one? Oh, sorry, let me go back so you guys are still right. Okay, for those who are writing, are you good? Do you need another second? Okay, cool. Alright, so now we're going to get to what is called the complex conjugates zeros theorem. Okay? It sounds complicated, but it's not. Basically, think of this as shoes. You always see shoes in pairs, right? You ever go to a shoe store? You're like, hey, I want to get that one. They're like, oh, sorry, but it only comes with the right foot only. Always come in pairs. Okay, what that means is all of your roots are going to look like this. If you have a plus bi, a minus bi is a root. It's always a plus or minus bi. So if I see one of my roots is 2 plus 3i, what does that mean has to be a root? 2 minus 3i. Good job, class. What if I'm told that for a polynomial, 5 minus I is a root? It would be 5, I heard it, what? Plus I. What if I have positive 6i? Negative 6i. Awesome. What if I have 8? No, don't you dare. No, it doesn't find that. Think of it this way. Remember, that's 8. So if I have 8 plus 0i, does that mean I'm going to have 8 minus 0? It's still 8, right? Okay. This only applies to the complex numbers. So I tried to trick you there. If you see imaginary roots, they come in conjugate pairs. But do real numbers come in conjugate pairs? No. So be careful on that. We're going to do some examples where I'm going to give you like some of the roots. And then the first thing you're going to do is figure out, are any of them imaginary? If so, they need to come in pairs. And add in those extra roots and go from there. So we'll see an example of what that looks like right now. Alright, so instructions here. Write a polynomial function of minimum degree in standard form with real coefficients whose zeros include just learned, if 2 minus I is a root, what else is going to be a root? 2 plus I, because they come in pairs. Good job, all right? Now, what about negative 3 or 4? Do I need to add in anything for those? No, because they're real roots, and real roots don't come in pairs, just the imaginary roots. Now, here's a question. How do we put these into parentheses? Well, it's easy with these. You just do the opposite, right? So instead of x minus 3, or instead of negative 3, what do we have here? Plus 3. And here for the 4 we have. Okay, now here's where you've got to be a little careful with your imaginary roots. It's always going to be x minus, and then in parentheses your root. Okay? So I'm going to do x minus, and then in parentheses 2 minus I. And then in this one it's going to be x minus, in parentheses 2 plus I. So with those complex, always do x minus, and then write the parentheses. Now, why did I put, like for this root right here, why is it 2 minus I in parentheses? What is going to be my very first step here with simplify? The negative gets distributed. If I didn't write the parentheses, I might forget that. So I'm going to make sure I distribute that negative, and then here I need to distribute that negative. Okay, let me back up a second. So what is this? This is our polynomial that has these roots, but this is in factored form. What form are we supposed to get it into? Which means what? How do you get it in standard form? You just multiply the whole thing out. Now, you might be looking at me like, this is going to be ugly. But since these are conjugates, what's going to happen when you multiply these together? The ugly goes away, right? Didn't that work on the other ones? Let me show you how to get the ugly to go away. So first off, distribute the negative. Okay, that's what we're going to do first. So I'm going to do x minus 2 plus I, because when I distribute, you got that right? And then here I'm going to do x minus 2 minus I. Okay, we've got a trinomial times a trinomial. Have you done that before? Maybe last year? Let me show you how I multiply trinomials. So I'm going to take the first term x, and I'm going to multiply it to all of these. So I'm going to write that out. That's x squared minus 2x minus ix. Then I'm going to go to the negative 2, and I'm going to distribute the negative 2 to all three of these. And I'm going to write it right below this. So I'm going to get negative 2x plus 4, and then plus 2I. And then I'm going to take the I and distribute the I to all three of these. When I do, I'm going to get ix, negative 2I, and then negative I squared. Okay, have you done that before, a trinomial times a trinomial? And then I'm writing it in rows like this. Now the reason I write it in rows is because the like terms end up on the diagonals. Do you have any questions on how I've done this row? Okay, so let's watch what happens here, okay? We're going to write out what's left over here. So x squared is all alone. Negative 2x minus 2x, that's negative 4x. Now let's look here on this diagonal here, okay? So looking on the diagonals, I have a positive ix and a negative ix. Those just go away. So I'm left with plus 4. We go to the next diagonal, negative 2i and a positive 2i. That's nice, they go away. And so for our very last term, we have a negative I squared. So what is I squared? So what is a negative I squared? Positive 1. So what this turns into, this whole thing is going to be x squared minus 4x plus 5. Did the ugly go away? We got the ugly to go away. Now, are we done? What we would still need to do is multiply this out, and then multiply it with that. Now, I'm not going to do that, because we don't have time to do that, but that's kind of, if it asks for it in standard form, that's what you need to do. But the most important part here, guys, is if you see an imaginary root, make sure you have its conjugate pair. When you put it into parentheses, make sure you do x minus the root like that, and when you multiply it out, the ugly goes away. Okay, let me just set up these last few for you real quick. We'll go from there. Okay. Actually, when I say I'm going to do it, I want you guys to do it. Okay? So, let's look at my roots here. I'm told one root is 1. Then I've got 1 plus 2i. And then I've got 1 minus i. So I want you to take 20 seconds and turn to your neighbor and say, what other roots does this need to have based on the given roots? 20 seconds, go. Alright, let's call on two people here. Let me get Lashea and Charlie. So Lashea, if 1 plus 2i is a root, what else needs to be a root? Good. Charlie, what if 1 minus I, what else needs to be a root? Good. How do I write this in parentheses? Well, the one that's easy is just x minus 1, right? Well, what did we say about writing the complex roots in? What do we do? And then parentheses, good, 1 plus 2i. And then x minus parentheses, 1 minus 2i. X minus parentheses, 1 minus I. And then x minus parentheses, 1 plus I. Now, what we would do here is which ones would we multiply out first? The ones that are conjugate to pairs. Multiply those out. Ugly goes away, multiply those out. Ugly goes away, and then when you're done, multiply them all together. Is that something you think you can do on your own? If you can do that on your own, you're awesome. If you're like, I need help doing that, come today after school, okay? Alright, we're going to hit the pause button there. I'm going to hand out your homework, and then we're going to review on Thursday and test on Monday.